In this practice problem, we want to use the mean value theorem to find c in the interval from 4 to 8. So the mean value theorem says that if our function is continuous over the closed interval from 4 to 8 and differentiable over the open interval from 4 to 8, then there exists some value c where the derivative at c is going to equal the slope of the secant line. So first, looking at this function, notice that it has a vertical asymptote at 0. But that vertical asymptote is not in our interval from 4 to 8. So in the interval from 4 to 8, this is a nice smooth function. So it's continuous in the closed interval from 4 to 8 and differentiable in the open interval from 4 to 8. So we know we can proceed with the mean value theorem and find our c. So the mean value theorem says that there is an s prime of c such that this equals a slope of the secant line, which is s of b minus s of a all over b minus a. So let's first find the slope of the secant line. So in this case, it will be s of 8 minus s of 4 over 8 minus 4. So let's find s of 8. Undo that. S of 8 is going to be negative 3 over 8 minus 8. So let's find a common denominator. This is negative 3 over 8 minus 64 over 8, which is negative 67 over 8. And then s of 4 is going to be negative 3 over 4 minus 8. Again, let's find a common denominator. So this is negative 3 over 4 minus 32 over 4, or negative 35 over 4. So the slope of our secant line is going to be negative 67 over 8 minus a negative 35 over 4, so we have a plus in there, over 8 minus 4. Let's find another common denominator. So we've got negative 67 over 8 plus 70 over 8 all over 4. And this is going to give us 3 eighths over 4. And if we multiply by the reciprocal, we'll have 3 over 32. So the slope of our secant line is 3 over 32. So we want to find now the derivative. So first I'm going to rewrite this s of x as negative 3x to the negative 1 minus 8, so I can use the power rule. And then s prime of x will be a positive 3x, so I drop down that negative 1, decrease it by 1, and we will have the derivative is 3 over x squared. So now I know that by the mean value theorem there exists some c where the derivative at that value c is going to be the same as the slope of the secant line. So I want to solve this for c. I have two fractions set equal to each other. The numerators are the same, therefore the denominators will be the same. And I'm going to take the square root of both sides, and when I do that, I'll get c equal to plus or minus the square root of 32. But negative square root of 32 is obviously not in this interval since the entire interval is positive. So we know that that is not an option for c. The square root of positive 32, so the square root of 36 is 6, and the square root of 25 is 5. So we know that the square root of 32 is between 5 and 6. Which is in our interval. So our answer is that c equals the positive square root of 32.